The ROV itself, the remote operated vehicle, is effectively a deployment platform. It's the vehicle that delivers whatever package you want to deliver. A bit like the space shuttle in a way. The space shuttle goes up and it's what you put in the space shuttle, including the people you put in the space shuttle, that delivers the unique benefit.
The ROVs are efficient because they reduce the time taken to actually carry out an activity. Historically, other means, long-reach tooling would have to be used, whereas the ROVs can be to the place of work quickly. They're also, in terms of efficiency, it takes the operator away from the radioactive field, so the operator can be in a remote area operating this equipment, doing work in a highly radioactive environment and not receiving any dose to themselves. And conventional health and safety, it removes them from the place of work.
The key to the value of the ROVs is in the tools that you apply to them and the team that design these solutions.
The video array is one of our latest ROVs. That's been operational now for about 3 years. And what we have done working with the manufacturers is develop it to a nuclear style. So it has coatings on it which can resist high pH water. We've altered the mechanics and the physical shape of it to be able to get into areas that the standard off-the-shelf model can't. It's primarily a good quality camera to be able to do videos. However, we've designed ourselves and worked closely with the company to develop a suite of other tools. We have a camera on a boom which allows us to rotate a camera tangentially to the ROV to be able to go between skips. We've designed tooling to be able to take oxygen samples and temperature samples from the sludge in ponds. One of the other uses that we've had for the video array is a small manipulator which is developed to go on the bottom of the video array. We've used that extensively to move small items of miscellaneous waste. Testing away from a nuclear environment is absolutely crucial for two reasons. Firstly, for individuals to gain experience on specific tasks, and secondly, to prove the equipment. What we found is having this test tank behind me is concept designs can be demonstrated and improved, working closely with our clients to look at how we propose to solve their problems, and from that we can evolve better techniques, better ways of actually achieving the end result. And that can only be done by physically testing equipment in this environment that I have behind me.
One of the key benefits of the rigs is actually being able to train people and to develop those skills so that when they go into the hazardous area, they've got those skills tied down and they can deliver the solution in an efficient, effective way, which reduces dose, reduces the risk to the operators actually at the cold face.
The ROV behind me is a small work class. It's the largest one we operate, but it would be considered to be a small work class ROV from an offshore point of view. The ROV itself is just equipped with a series of thrusters, buoyancy. It's fairly simple, and some good quality CCTV cameras and LED lighting. What we have developed with that ROV is the capability to put on a whole suite of skids which have various functions which can be added onto that ROV to do specific tasks.
We design those skids to basically deliver whatever solution to whatever problem our clients have. For example, in terms of pumping sludges, we've designed skids to deploy pumps for pumping sludges out.
One in particular is called a pick and place skid, which is a manipulator on the underside of the ROV, which is designed to be deployed and pick up miscellaneous waste from the bottom of the fuel ponds.
So the ROV is just a delivery vehicle. We then design the attachments that go onto that to actually solve the specific problem. And really it's limited by the imagination of the designers and engineers. If you can define the client's problem, then you can design the right solution. One of the main benefits that I've seen of the test facilities here is in stakeholder management. What I've tended to see happen is people gravitate towards the rig. The rig becomes a focal point of the stakeholders to help them understand the kind of solution that we're trying to deliver, to help them understand the innovation that we're trying to introduce. What we don't do is reinvent the wheel. We've got a whole bunch of various suppliers who supply us ROVs. So what's the point in us designing our own? It doesn't deliver value to our clients. We deal more with innovation, which is taking that certain item and this certain item and putting the two together and going, if we put those two together, it can do this. And that's the innovative thing. What delivers value is our innovation, is how we apply those existing tools and other existing tools and put them together to deliver the solution. A rig hall's a building unless you combine the skills of the people with the rig hall. You don't get full benefit from it.
We'll test equipment over and over again, and from that we learn. Not every time do we get it right first time, so therefore there may be some re-engineering.
What we've got is a multidisciplinary, multi-skilled team here of design engineers, electrical and mechanical, control systems, engineers, craftsmen. These are the guys that can make the reality out of the designs that the guys come up with.
So when the teams take the equipment to site, they've got the confidence that A, they know how to operate it, and B, it will work in a nuclear environment.